This unit is about vectors. When we say vectors in a plane, we just mean that we're going to be using two-dimensional vectors. We're going to start off with arithmetic of vectors. First, we'll cover the definition of a vector, some symbols and notation, what it means to have equivalent vectors, the component notation, and then talking about calculating magnitude and direction. A vector is anything that has both magnitude and direction. Things like area, volume, length, temperature, time, they only have a magnitude only. We can't measure, the volume. The volume wouldn't change if it was moving in a different direction or anything like that. So direction doesn't really have an impact on those. Things like velocity and force do. If I push you forward, that has a different effect of pushing you backward. Or if a river is flowing downstream and you paddle with it versus paddling against it, those two things have very different effects on you. Some people call vectors directed line segments. We'll just stick with the word vector for the most part. If we talk about vector PQ, we use the arrow to show that the vector is starting at point P, the initial point, and ending at point Q, the terminal point. That indicates the direction of the vector. So magnitude is the length of the vector, and vice versa. The length of the vector gives the magnitude determines the length of the vector. We can either use a single bar on either side or a double bar. And we could also write vectors as bold letters. It's hard for you to show bold letters in handwritten work, so we put small arrows over the top of the letters to indicate that they represent vectors. Two vectors are said to be equivalent if they have the same magnitude and direction. Location doesn't really matter, so if we start at 0, 0 or start at 5 and 1.5, it doesn't really matter. We can get the same equivalent vector. Location doesn't matter. The component form of a vector describes kind of the pathway that the vector takes, and this will make more sense when I show you a picture of this. If it starts at 0, 0 at the origin, then the component form is the amount we go left and the amount we go left or right and the amount we go up or down. If it's not in at point 0, 0, then we have to do a little bit of calculation before we know its components. So this really comes back to right triangles and stuff that we've done a lot of. This one, instead of saying V1 and V2, it said A and B, but it was a really good diagram, so I didn't want to lose it. So the way that we're going to be writing our component form is going to look like this, where V sub 1 is our X direction and V sub 2 is our Y direction. If I was located somewhere else, if I was up here, going up here, then we would need to know this distance by subtracting, taking the x of the final point minus the x of the initial point, and we would find this distance by subtracting the y of the final point and subtracting the y from the initial point. Really, that should look very similar to the distance formula, which is what we're going to use to find the magnitude. Since the magnitude is the length, we use the distance formula. So this, something else, you might have seen this in other places like in physics class. We have delta x and delta y, which makes the distance delta x squared plus delta y squared, and the square root of that. An example here, finding the component form and length of a vector that starts at 4, -7, and has a terminal point of -5, 1. Find the direction of vector V. I'm a visual person, so I like to sketch things out. We start at 4, -7. and we end at negative 1, 5. So I'm including an arrow to show this. Here's my v sub 1, here's my v sub 2, my x component and my y component. My delta x, in other words, is going from 4 to negative 1. We're going down 5. My delta y, we're going from negative 7 to positive 5. That's an increase of 12. So the component form of vector v here is equal to negative 5 comma 12. And I probably didn't mean to write direction here. I want to find magnitude. And so the magnitude of vector v is going to be negative 5 squared plus 12 squared. And we're going to take the square root of that. That's a Pythagorean triple, and we get 13 for the magnitude. I'll have you answer this question on your own. We're going to have u as a vector that starts at r and ends at s, and v starts at 0, 0 and ends at 3, 4. You can do this on your notes. You're going to sketch the vector on the coordinate plane. What I want to know, what you'll answer is, are they congruent? Alright, that's it. If you have any questions, make sure you write them down in your notes so you can ask me tomorrow.